Okay, so today we're going to start. Okay, put your phone away. Like away, not just down. There's a difference. Thank you. Okay, so we are doing volume today, or starting volume. Okay, so everyone get out your volumizing root spray. Just kidding. I'm talking about figures, not hair. Okay. So the volume of a three-dimensional figure is going to be the number of non-overlapping unit cubes of a given size that exactly fill the interior. Now, that's kind of a lot of words. But if you think about like a Rubik's Cube or something like that, what is it, like 3? It's like 3 and 3 and 3, right? For a Rubik's Cube? Okay. So if I draw like this, okay, so you can see that I've got my 1, 2, 3 for this side. Oops, boop, boop. I've got 1, 2, 3 for that side, and then I've got a height of 1, 2, and 3. You can imagine how I would have like 3 layers, right, of 9 cubes. Can everyone picture the 9 cubes? Like if I look at the top of this, it kind of looks like a tic-tac-toe board. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9, 9, and 9. Does everyone see that that's just the length times the width times the height, right? It's the number of non-overlapping cubes of whatever size we designate that fill up this volume. Cool? Okay. Now it gets a little bit exciting when we don't have like rectangular or like objects, right? If we have round objects, we have to kind of throw in a pie in there and it gets a little weird. But we're going to be using some of the same tricks. So let's just start with the cube because that's the one we were just talking about. If all the sides are the same, then the length times the width times the height is just s times s times s, which is s cubed. Easy enough, right? Okay. For a right, anytime it says right, that means like 90 degrees, right? Okay, so what that means is it's not going to be slanted at all. All of the angles for this prism are going to be right angles. You can think of like a Kleenex box, okay? That's what I always think of. This will just be our length times our width times our height. Okay, what? Yeah. Now it gets a little bit more exciting when we have a prism that is not all rectangles or if it's slanted. So let's talk about this one first. You all know that the area of a triangle, area equals 1/2 times the base times the height. What do you notice about the letters in this formula? Okay, it's a little bit more subtle. Do you see that the A is capital? Okay. So the A is capital. That means that this is an area. Well, duh, right? It's literally an area formula. Okay, do you see that the B and the H are lowercase? Here, let me put this down here. These are lowercase. Jeez, my brain stopped working. Lowercase. Okay, and that means that these dimensions are not areas, they are linear dimensions. They're like lengths, okay? Lengths. They are linear. So this area is like 2-dimensional, and these linear ones are 1-dimensional. Does everybody see the difference?
Yes.
So the convention is in these mathematical formulas, and this is going to help your brain a lot, is when we have lowercase letters in our formulas, those are going to be our linear measurements. anytime we have an uppercase letter in these formulas, it's going to represent an area, okay? So when I look at this and I see volume is base times height, it's not the same base as the base in this formula. That is a linear measurement. This is an area base. Everybody see the difference? Yeah. Because it's capitalized, okay? The height is a lowercase h, so that's a linear height. It's the same kind of height as for a triangle. Linear height. So if you have the kind of cutesy handwriting where you kind of like mix up capital letters and lowercase letters because it's cute, like you can't do that in this math class anymore because the lowercase letters and the capital letters mean very specific things. Does that make sense to everybody? Right. Okay, you can do that in every other class, but not in here. All right, so if we find the area of the base and multiply it by the height, that's going to give us the volume of this figure. Cool? Same with this one, except that like some of our crazy triangles, the height can be outside of the figure itself. Okay, if the height is the distance from the base to the base, the perpendicular distance. Remember that height is always perpendicular to the base. Cool? All right, here we go. We just have to find the volume of this prism and round to the nearest, what does it say? Hundredths. Okay. So we have a right prism. So all we have to do is multiply base times length times width times height. So our area equals length times width times height, which would be 13 times 3 times 5. So what's 13 times 15?
225.
What is it?
225.
225. Is it really? No, that's not right. What is it?
It's 195.
It's 195. Now, these are not linear measurements. It's not an area like an area rug. These are cubes, right? These are cubic units. Okay, so I have to say centimeters cubed. Oh, I said area. Good grief. Can you tell we've been doing a lot of area?
Oh, what should it be?
What do you think it should be?
Volume.
Volume. Sorry, my bad. Okay, I got that out of my system. Now you guys know what to watch for. Okay, any questions about that one?
No.
Does it say we have to do anything else?
Yeah.
Okay, that was fun. All right, if we have a cube, what do we know about all of its sides?
They're equal.
Yeah, they're all the same. So if we have an edge length of 15, okay, the length, the width, and the height are all going to be 15.
Yeah.
So our volume is just 15 times 15 times 15, or you can think of that as 15 cubed. Doesn't matter to me or your calculator. I don't know what that is either.
3,000.
What is it?
3,375.
3,375 inches cubed. Yeah.
So would a circle just be pi radius?
Okay. Now we have to find the volume of a triangular prism. Hold on. With a height of 9 yards and a base right triangle with legs of 7 and 5 yards. Oh, geez. All right, maybe let's draw a picture. Did you know we were going to draw a picture?
No.
Okay, you get to see my horrible picture drawing again. Okay, so let's make this a 7 and this a 5. Okay, it's a triangular prism, so that means that we'll have two bases and they're both triangles. Oops, actually that one would be, oh my gosh, I'm not good at drawing this, guys. Okay, oh, that's not terrible. Could have been worse, right? Okay, what is the height? I'm seeing 9 yards. Okay, so our volume is going to be our capital B base times our lowercase height. So that's going to be an area times a height. So we have to find the area of the triangle and multiply it by the height. Okay. So if I'm finding our capital B, that would be 1/2 times the base times the height of our triangle.
Are we doing the bottom and the top one?
What?
Like, can we find the base of it? Or are you talking about like both of them or just one?
Well, we just need one. When we're talking about surface area, we'll have to use the top and the bottom and add them together. But when we're talking about volume, we don't multiply it by it twice. We just find the one area of the base and multiply it by the height. Okay, so we're going to find this area of the 5 by 7 right triangle. Okay, so the base is 1/2 times 5 times 7. So half of 35 is what? Is it 17.5?
Yeah.
Okay. And then this height isn't going to be the height of the triangle, it's the height of the prism. Okay. So our volume is going to be the 17.5 times the height of the prism, which is 9. $157.5. Okay. And that is cubic yards. Okay, that wasn't too bad. Just be careful when you're talking about the heights because we obviously had the height of a triangle and then the height of the prism, and those were two different H's.
Right.
Okay, so it might be helpful to you to draw a little sketch off to the side like we did so that you don't get confused. All right, here we
If I
go.
could add something, I think the key is also, how many bases can you have?
Okay, so Coach's point was that we have to make sure that our bases are the ones that we only have one or two of. Like this has to be the base and this has to be the base. We can't say that the bases are the other faces of this prism. Okay, thank you,
If it was
Coach.
flipped over, remember, there can only be two bases in a triangular prism,
Okay.
not three.
So, for example, this one, just because it's sitting like a tent doesn't change the fact that the base still has to be this face.
Right.
Does everybody see?
Yeah.
Okay, that was a really good point. Okay, so let's find this one. Volume is our big area base times our linear height. So we have to find our big area base for this triangle. Okay. So that'll be 1/2 times the base and height of that triangle, which if I just sketchy poo it over here is 13 for the base, and is that 11?
Yeah.
11 for the height. What's with all the odd numbers, Mrs. Madsen? Jeez. Okay, you said 71.5. Okay. 13 times 11. Okay, now that we've got our area base, we can plug that into our volume formula. So volume equals our 71.5 times the height of our prism, which is, what is that, 15? 786.5, and that would be cubic feet. Did we mess up? Yeah.
What do you mean twice that? Well, because you saw.
Okay, so it was 1072.5. Cubic feet. Okay, any questions about this one?
Nope.
Okay, perfect. Okay, I want everybody to take a second to figure out where the base is. Where? Okay, so it's tempting to say that this is the base, right? But it's not. Okay, that is not the base. That's just that's just the face that it's resting on. We don't have a face that's congruent to that one. The bases would be this face and this face. Those are the base faces. Yep.
If you had a cone, but the top of the cone.
And this little cone. Okay, so our volume equals our area base times our linear height. So we need to find our area of our base. So I'm going to draw my little triangle over here. And it's got a height of 3 and a base of 5. So my area for my base is 1/2 times 3 times 5, which I'm being told is 7.5. Okay, so I'm going to plug that in. So my volume is my 7.5 times my height of, is that 7?
Yeah.
Geez, with the odd numbers. All right. 52.5, and this will be cubic yards. Okay, so it has to be cubic yards because this 7.5 is yards squared, and this 7 is yards. So I have yards squared times yards to the first. And when I multiply same bases, I have to add my powers. 2 plus 1 is 3 for the power. Okay. Volume of a cylinder. Okay, so even those cylinders that are slanted, what I want you to notice about their sides is that they are parallel. Okay, so the figure that Grant was asking about, those sides were not parallel, so we had to treat that like some cones, right? So we can only use the cylinder ones when our sides are parallel. Okay, So the volume of a cylinder with a base area B, a radius R, and a height H is the area base which for a circle is pi r squared. And if you plug that in to replace the big area B, the formula looks like this. So you can use either formula. They're the same. Okay. Which one? You got to do what works for you. So our volume is our big area base times our height. So let's draw a picture of our circle base. These are the bases. Pew, 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 pew. Okay, it says that this is 18. So if I wanted to know the radius, what would the radius be? 9. Okay, and then that's really all we need for the area base. So pi times r 9 squared. So I'm getting 81 pi. I'm going to round at the end instead of in the middle, okay? All right, so now I'm going to plug my area base in. Volume equals 81 pi times the height of 14. And what did you say it was? Okay, it says in terms of pi and also rounded. So let's do the 81 times 14 first, and we'll write it in terms of pi.
1,134.
1,134 pi.
Yeah.
Inches cubed, and then
3,562.
3,562.57 inches cubed. Thank you. That wasn't so bad. Was that the end? Okay, we need to find the volume of a cylinder with a diameter of 16 inches. Let's draw a picture. It's all right, neither can I, and I'm up here like doing my best. Oh, that should be solid. Okay, so it's saying that the whole diameter is 16 and the height is 17. Okay, so let's find our volume. And let's make a picture of the circular base. So if the whole diameter is 16, what is our radius? 8. So our base is pi times 8 squared. I'm getting 64 pi. So our volume.
You're going a little fast.
Yeah. All right, I'm going to slow my roll. I've been told that I can continue. 64 pi times our height of 17. So we have to give this in terms of pi and rounded. 1,000 what? 88. Thank you. Pi.
Oh no, I broke the wrong thing.
Inches cubed.
No, why are you going so fast?
I'm not. I just wrote inches cubed. Gosh. 3,418 point what? Okay, is this our last one?
No, we have example 4A and 4B.
G means like added together. Okay, so we're going to find the volume of this composite figure, and we're going to round to the nearest hundredth. So let's start with the weird little triangle on the top. Is everybody okay with, if this is 8 centimeters, then this one is also 8? Okay, so this one is also 8. So what we have here is an equilateral triangular base for that triangular prism. Okay, so let's start with that triangle. Okay, so if this is 8 and this is 8, and I make my height perpendicular, okay, then this is 4 and this one's 4. Okay, remember that this was an equilateral triangle, so it's also equiangular. So this little angle here is 60. And what's this one? Did I hear 30? Okay, 30 is right. So we have a 30, 60, 90 triangle. And we know that this little short leg is 4. What does that make our long leg? And that's our hypotenuse, 8. What? Not 12. Yeah, 4 square root of 3. So I'm asking about this leg, the height. Okay, so that leg is 4 square root of 3. That is the height of our triangle. Okay. So the base for the area base is 1/2 times the base of the triangle, which was 8, times the height of the triangle, which was 4 root 3. So I'm getting 16 root 3. For that B. Okay, so the height of that prism is 4. Good. So our volume is going to be our base. Base times height. Let's write this as like, this is for a triangular prism plus this length times width times height for our rectangular prism. Everybody okay with that? Because I have to add those two together. Okay, so our base is the 16 root 3 times the height of 4 plus the length of 8, width of 5, and height of 4 for our rectangular prism. Does it matter which one I make the length, width, and height for the rectangular prism? No. Because it's just multiplication, and multiplying is commutative, so I can multiply them in any order. And we're rounding to the nearest. Did you do it all at once on your calculator? Okay. So what was it?
270.85.
270 point. That seems low.
That's what I did.
Yeah. Yeah. Okay. 270.85. Sorry to have doubted. 270.85, and these are cubic centimeters. Perfect. Done.